Good morning, class. We are looking at final exam review covering from 1.6 to 5.4. Let's quickly cover what we went over last time. Differentiation formulas. Logarithmic properties. Integration formulas. Differentiation using the power rule or the extended power rule. Implicit differentiation, derivative of sinusoidal functions. Application problem, related rates. Implicit differentiation where t is the independent variable. Application problem, related rates again. Discussion of limits. We plug in and we observe. If the result is a number, we are done. If 0 over a number, it is equal to 0 and we are done. If it's a number over 0, we have to figure out if it's positive or negative infinity. Finally, we have indeterminate forms of 0 over 0, infinity over infinity, or infinity minus infinity, which requires more algebraic work. We did it here, and one technique is factoring. We looked at more examples here. Also an example of a differentiation. On this page, all of them end up with 0 over 0. One technique is factoring. The other one is LCD, multiplication by the least common denominator, when we have a complex fraction. And in the last case, we multiplied and divide by conjugate of the numerator. Differentiation using the product rule, and then looking at logarithmic differentiations. We had the expression for f of x. We wanted to differentiate. We wanted to integrate on the same page so we could compare and contrast. Also, we looked at an initial value problem for this case. Dealing with the natural log. In the case of integration, normally natural log is the choice of u. With the u substitution, we ended up with the final answer. And in this case, exact answer. Here we go. We are looking at to evaluate this integral. And the steps involved are very simple. Make up two fractions. Even if we were differentiating, that would be the case. Simplification gives us this. So far from here to here is simply algebraic technique. Now, in this case, 1 over 1/2 plus 1, x to the power of 1/2 plus 1. In this case, 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1, and a constant. 1/2 plus 1 is 3/2. So this one is 1 over 3/2 or 2/3. This one is 1 over 1/2 or 2. The point of this question is going from here to here algebraically in no time using the power rule. Anytime you have a fractional expression, your first step is to simplify if you can. If you cannot, normally the denominator is a choice of u. Notice the derivative of the bottom is the top. Therefore, when u is 5 plus e to the power of t, du is e to the power of t dt. Also, it is absolutely important that we write this before we go to the next step. In other words, I cannot go from here to here without stating the fact that we are using u equals 5 plus e to the power of t, resulting in du being e to the power of t dt. This is a natural log. We finish the job by replacing the u with its original choice. Now, This we can use a parentheses because this expression is positive. Anytime we're dealing with exponentials, the exponent is normally the choice of u. In this case, we notice when we do that, we need number 5. Since putting x to the power of 4 next to dx shows number 5 is missing, we can multiply and divide by it because the product of 5 and its reciprocal is 1. So 1/5 the integral of e to the power of u du, which gives you 1/5 e to the power of u and a constant. Replace the u, and we are done. Let's look at part A and its reciprocal, because I want to compare and contrast. This one, we go through the process of the u substitution. This one, we just make up 2 fractions. 5 over e to the power of t plus e to the power of t over e to the power of t. Now, there is no need for a substitution. The first one, 5 divided by -1, gives us -5 e to the power of -t plus 1 gives us t. Pay attention to the fact this is dt. Therefore, use the appropriate variable and a constant. Anytime ln x is involved, that is a choice of u, at least for us. We can rewrite this if need be, so we can see what we are dealing with. So we are dealing with u squared times du, which uses the power rule. Replace the u, we are done. In the case of a fractional expression, always check to see if you can simplify. When we cannot, if we choose u to be the denominator, I hope you realize the derivative of the bottom is the top, therefore du is the top times dx. With the u substitution, we can see easily the answer is natural log. Replace it, we are done. This is also an example that I could use parentheses because this expression e to the power of x plus e to the power of minus x is always positive. Otherwise, we cannot. Going back to the beginning of the course discussing limits, a doctor prescribes a 300 milligram drug to be taken every 12 hours just before each tablet is taken. 40% of the previous amount of the drug remains in the body. So we are following the formulas here that was discussed in the beginning of the course. Anytime you have an application problem, it is important to write the given. So when you start reading, this is being repeated every 12 hours. So this is the amount of constant. So this is the constant. 12 hours, extremely important, doesn't enter the equation. What matters is what remains. What remains is 40% or R equals 0.4. And in the beginning, there is no drug. So to begin with, Q sub 0 or A is 0. The reason we are using Q, if you go back here, we used B and B sub 0 or A. In this case, part A shows us that they want us to use Q. Therefore, for the first portion, write the expression for Q sub n plus 1 in terms of Q sub n. They are asking for this. So I'm going to look at this formula and change the B to Q first and foremost. Now, look at the given. Replace anything you must. So replace the R with 0.4. or 40%, and the constant with 300. We want to find the formula for Q sub n as a function of n. That means we want to go here and use this formula, and we're going to change B sub n again to Q sub n. So let's rewrite this formula with Q sub n, simply because B is being changed to Q. Now let's replace it. Go back to the given. Go back to the given, and now replace Q sub 0 with 0, or with 0.4, C with 300. Let's see what happens. 0 times any number is 0. We change 1 minus 0.4 to 0.6, and we can see that it's the same as writing 300 over 0.6. We can put that underneath 300, which is 3,000 divided by 6, which is 500. The reason we do that is for the last part when we want to find the limiting factor. How much drug is left after the 5th tablet? I hope you remember what we did before. When they asked it in the beginning, we would make up a table and basically use this formula. That's the concept. N equals 1, N equals 2, so on and so forth. Okay. Now, because we have this formula, replace the N with 5. And that's your answer. The last part is asking us to take the limit of a part B. So we want to take a limit of this expression. As n goes to infinity, 0.4 to the power of n goes to 0. I hope you remember that, because anytime the base is between -1 and 1, and n goes to infinity, the exponent, the expression goes to 0. So this goes to 0, we get 500 times 1. As n goes to infinity, this goes to 0. And it's an application problem. We're going to answer it with its unit, 500 milligrams. We've done this question a number of times, including the last exam. Many fish grow in a way that is described by the von Bertalanffy growth equation for a fish that starts life with a length of 1 centimeter and has a maximum length of 30 centimeters. This equation predicts that the growth rate is 29 e to the power minus x centimeters per year, where x is the age of the fish. How long will it be after 4 years? We use the definite integral, the net change theorem, to find the amount of increase, because this is the growth rate. So this is, if L of x represents the length, this is dL dx or L prime of x. And so the amount of increase is this integral, the integral of this times dx, from 0 to whatever the question is asking, 4 years. So this is the explanation we had before. Now the time is changed to 4. We can find the amount of increase. We've seen this many times before. We evaluate the integral from 0 to 4. We write it with a bunch of decimals, and then we add the initial amount of 1. Remember, the initial size was 1 centimeter. And we go with 1 decimal because they said so. If they don't, you have to put tons and tons of decimals, or precise answer, as you've seen this before. The second method, and again, all you have to do one method. Because we found this, L of x is this thing plus a constant, with the initial size L of 0 equals 1. Plug in 0 instead of x, 1 instead of L of x, and you find the constant of 30. This is a function at any given time. We want it at x equals 4. And that's exactly what we got here. We want to integrate a rational expression. The first step is simplification if we can. Since we cannot, in this case, use the denominator as a choice of u, its derivative is the top, therefore du is the top times dx. It's the integral of du over u, which results in a natural log. Replace the u, and we are done. Now, this expression can be positive, can be negative. Therefore, we must leave it in an absolute value sign. Part B is similar to part A. However, we can factor and drop the common factor of x minus 1. And that's the main difference. In other words, a rational expression, simplify if you can before you move on. Now we are dealing with this expression times dx, 4 over 2x plus 3 times dx. We want to integrate that. Let u be the bottom, and the u becomes 2 dx. So remember, the top is 4 dx. That's why it generates a number 2 outside. So it's because it's 4 in the numerator. This is a natural log again. Replace it, and you keep the absolute value sign because this expression 2x plus 3 can be positive or negative. Now, again, to emphasize what happens with a rational expression, I'm going to look at the same question, part B, but it's reciprocal. And therefore, when I want to factor this, I get the reciprocal of the green one, right? So B and C, they are reciprocals, okay? The expressions inside. Divide this one by this one, and divide this one by this one, and you don't have to do substitution. 1/2 times x. X gives you 1/2 x squared, so the result is 1/4 x squared, plus 3/4 x and a constant, and you're done in no time using basically the power rule. Equation of a tangent line. As always, we need 2 things for finding any line. We need a pair, and we need the slope. To find the slope, we differentiate. Now, if I plug in 4 here, 2 times 4 minus 3 equals 5, that is the slope. X is 4. If I plug in 4 here, 4 squared is 16, minus 3 times 4, which is 12, makes it 4, minus 1 makes it 3. I have the pair 4, 3. So I have the slope, I have the pair. I use y minus y1 equals m times x minus x of 1 to come up with the answer. Y minus 3m 5 times x minus x of 1, 4 results in y equals 5x minus 17. By the way, assuming this slope is correct, you want to check by plugging in the pair. The pair works with the original function. It is also on the tangent line. The distance in meters of an object from a starting point is given as follows. S of t equals 2t squared minus 5t plus 40. T is time in seconds. What is the average velocity? Average velocity is the total distance over total time. A simple example, again, I've repeated that many times. Cover 100 miles per hour, that means 50 miles per hour is your average speed. Therefore, we use this formula. We evaluate the distance at 4. We evaluate the distance at 2, their difference over 4 minus 2. We end up with 7 meters per second. This is the average velocity. What about instantaneous velocity? Differentiate after 6 seconds, plug in 6. And I hope you realize they have the same units. The average and instantaneous velocity, they have different formulas, same units. Also, the question is asking for the acceleration, and acceleration is the second derivative of the position function or the first derivative of the velocity function. So A of t is v prime of t or s double prime. So differentiated again, because it is a constant. Whether it's after 6 seconds or 10 seconds makes no difference. It's the same thing. 4 meters per square second. And the reason for the units, because v of t is delta s over delta t, but a of t is delta dv, I should say, over dt. And the units of the numerator over units of the denominator gives you meters per square second. When does the object reach the velocity of 31? You use this formula, set it equal to 31, and it gives you the t equals 9 seconds. Using differentials to approximate square root of 27. I have the synopsis of what needs to be done by looking at the graph and the formulas here. If you look at the graph, you have the curve. As we go from one point to the next, it creates the distance along the x-axis known as delta x or dx. And it creates a distance along the y-axis called delta y when you're looking at the curve. If you draw a tangent line at this point, now it creates a distance along the tangent line called dy. So delta y is this, which is precisely f of x plus delta x minus f of x. Dy is this, which is precisely f prime of x dx. They're not equal, but we can approximate delta y by dy anytime things become difficult. So for a case like that, number one, you need a function. Because we want square root of 27, the function would be f of x equals square root of x. You have to write that. Let f of x be square root of x. You have to choose a number close to this such that we know square root of that easily. For that, obviously, the closest number to 27 is 25, because we know the square root of 25 is 5. And from 25 to 27, that gives us delta x or dx of 2. So from 25 to 27, in other words, delta x is 27 minus 25, which is positive 2, meaning what? Meaning we know the square root of 25 is 5. We don't know the square root of 27, but it goes up because delta x is positive. On the other hand, if I wanted to find, let's say, square root of 24, then delta x for 24 would be 24 minus 25, which is negative 1. And again, what does it mean? From 25 going to 27, this must be larger. That's why delta x or dx is positive. From 25 to 24, this must be smaller. So that's why delta x is negative. And this sign makes a huge difference. If you don't pay attention to that, your result will be wrong. So f of x plus delta x is f of x plus delta y. Delta y is approximated by the dy. Remember, this is exact. This is an approximation. So f of x is square root of x. We know by now f prime of x is 1 over 2 square root of x. We've done it many times, or just write square root of x equals x to the power of 1/2. You want to differentiate that, you get 1/2 x to the power of 1/2 minus 1, or negative 1/2, which is 1 over 2 square root of x. Therefore, dy is the same thing times dx. And the formula for this expression becomes f of x, delta x, plus dy, or 1 over 2 square root of x dx. We want square root of 27. That means we want f of 27. And that means we are going to replace the x with 25 and the x with 2. So I hope you see all these steps. This is how you're supposed to write step by step when you do this problem, so you can remember the process accordingly. Square root of 25 is 5. Square root of 25 is 5. These two cancels out the 2. So you get 5 plus 1/5, which is 5.2. Now, I hope you remember this can be done by linearization. What is a linearization? Just find the equation of this line, tangent line, at x. And remember, x is 25, everybody. And you don't have to even memorize any of this. Y minus y1 equals m times x minus x sub 1. So if this is the case, and never mind the rest, what is my pair? Remember, at x. So you're looking at this function. X is 25. F of 25 is 5. So the pair is 25, x is 25, and y is 5. What about the slope? I need the slope. Well, here's f prime of x. Replace the x with 25, and you get 1 over 10. So using the pair and the slope, you can find the y. After you find it, replace the x with 27. It gives you precisely the same answer we got here. I highly recommend you guys do that. You want to make sure you can do both ways to be on the safe side. Find the absolute max and mean for this function on the given interval. This is called closed interval theorem. And the method says if a function is continuous in that interval, we can use the method. What type of a function is that? You have to prove to your reader this works. So this is a polynomial of degree 4, which means you have to write the domain from negative to positive infinity. Therefore, it's continuous from negative 4 to 1. So that's the first thing. Now the methodology says find f prime and set it equal to 0. Let's do that. 4x cubed minus 18 times 2x, or minus 36x. We factor the 4x out because of the next step. X squared minus 9 is x minus 3x plus 3 in any order you want. When we set this equal to 0, this becomes 0. This becomes negative 3. This becomes positive 3. So there are 3 critical points. Again, x is 0. Is it in between? Yes. X is negative 3. Is it in between? Yes. X is positive 3. Is that in between? No. Therefore, we cannot use positive 3. We evaluate the function at these 2 endpoints, as well as what we can 0 as well as negative 3 are in the interval. Remember, this is an element of, I've mentioned that in the beginning of the course. Plug in 0, plug in negative 3 also. We end up with the following. Largest number is 0, so absolute maximum equals 0 at this pair. Smallest is negative 81. Absolute minimum is negative 81 at that pair. You want to pay attention to the way the question is asked. Many times they just ask you for the absolute max and mean. I just wanted to be clear that this is the absolute max, the y coordinate, and this is the location. Evaluate the integral. The purpose of that is to see how a definite integral is evaluated with the substitution method. So there are two methods. We can do the math and go back to the original variable first. So let's look at that. U is 25 minus x squared. The u is negative 2x dx. So notice negative 2 is missing when I put the x next to the x. So I'm going to multiply and divide by it because it's just a number. And when I use the u, I'm not going to write the limits yet. I'm going to continue on that thoughts. And this is the simple integration of the power rule. In this case, 1 over 1/2 plus 1, u to the power of 1/2 plus 1. 1/2 plus 1 is 3/2. The reciprocal of that is 2/3. Again, I'm going over this fast. We've seen it a number of times. Resulting in the following. I haven't used the limits for u yet. We can go back to the original variable and original limits. Or if I plug in 3 here, 25 minus 3 squared, that means minus 9, gives me 25 minus 9 or 16. If I put 4, 25 minus 4 squared, 25 minus 16 gives me 9. So I can use those limits. We've seen this, everybody. I have also gone over this quickly. Square root of 9, which is 3. You're going to cube that, you get 27. Square root of 16, which is 4. Cube it, you get 64. You want the difference of the two times negative 1/3. The radius of a blood vessel is given as 1.4. A drug causes it to change to 1.3. Use the differential to find the approximate change in the area of a cross section. Cross section is in the form of a circular shape where a is equal to pi r squared. R is the initial value of 1.4, and it goes down to 1.3. Therefore, dr or delta r is the new one minus the old one, creating a negative sign. I can't emphasize this enough. Okay, original one, negative. Now we are using a equals pi r squared. Because of the approximation using the differentials, that means dA. So first you find a prime of r, if you will, which is dA dr, and then dA becomes that times dr. That's what the process is. So differentiate this with respect to r, you get 2 pi r. We can call this a prime or dA dr. So what is dA? 2 pi r times dr. So go back to the given. That's why we translate with the given. It's really helpful when we want to answer it with details and properly. So replace the r with 1.4, but dr with negative 0.1. And what it really means that it's shrinking. That's why the sign is important. And you would leave it like that. If they ask you for a decimal representation, then they would ask you how many decimals. I've done them both in case. But we can also find the exact change. Instead of dA, we can find delta A. What is the change in area? We find the area, here's the formula, with a radius of 1.4, and then with radius of 1.3. Their difference is the exact change. And of course, area with 1.3 comes first because we want to see the change that becomes negative. A farmer with 240 feet of fencing wants to build an E-shaped enclosure besides a creek. As seen in the diagram, find the maximum area that can be unclosed. It's important to have the setting, everybody. If X and Y are not there, you want to put them there. So the objective is to what? Maximize the area X times Y. And we have only 240 feet of fencing, which is 2X plus 1Y, because one side doesn't need it. And now we are in business. You can solve for Y. Becomes 240 minus 3X. Therefore, the function A, which contains two variables, now will have one. That's the reason we do that. Now, why is it that X is between 0 and 80? X is a dimension must be positive, and Y it can't be larger than 80. This expression, the parentheses, if you choose a number, if you set this equal to 0, becomes 80. Larger than 80 makes this negative, the area becomes negative. We distribute because now we are ready to differentiate. A prime is 240 minus 6X. We set it equal to 0 to find the critical point. X becomes 40. Now, it's important for everybody to understand when we come this far, all it means we found the critical point. Is it going to maximize or minimize? We have to show the work. How? Well, let's find A double prime. We have to evaluate the A double prime at this point. However, it is a constant, then you don't need to. If it were, let's say, minus 6X, you would plug in 40. Negative means concave down. Concave down. Concave down, looking like that. Maximum occurs there. If X is 40, use this to find the Y and the area.